Inverter.
Welcome to ClickMyProject.com. The title of the project is Fault Knowledge Transfer Assisted Ensemble Method for Remaining Useful Life Prediction. And the abstract of the project is Machinery Remaining Useful Life Prediction is an important task in condition-based maintenance. The condition-based maintenance is a maintenance strategy that collects and assesses real-time information and recommends maintenance decision based on the current condition of the system. In this process, we propose a fault knowledge transfer assisted long short-term memory neural network and greater recurrent neural network method for remaining useful life prediction. Divergence, minimization, and domain adversarial adaptation techniques are combined to transfer fault knowledge from a fault dataset to the run-to-failure samples. With the diagnosed fault condition information, the remaining useful life prediction network can learn various degradation patterns under different faults using the structures of long short-term memory neural network. Then a greater recurrent unit process based on predicted sort fault conditions are proposed to get remaining useful life prediction results. Finally, the algorithms are implemented and generate the results in the form of matrices like accuracy, precision, recall, and FN score. And the flow diagram of the project is, first we need to start the program and select CWRU dataset. Then we use the sample dataset in our console working directory. The CWRU dataset is the fault bearings, the type of fault bearings. And after that it will apply into data preprocessing. In data preprocessing we are going to clean our dataset. Like in that we are going to check the null values in our dataset. After that it will process into model selection. In model selection we are going to split our dataset into training dataset and testing dataset. After splitting dataset, in classification we are going to apply the two different deep learning algorithms to analyze the fault and identify the type of bearing faults from our CWRU dataset and generate the results in the form of matrices like accuracy, precision, recall, and FN score. The program was successfully executed in Anaconda Navigator Spider IDE, and this is the sample dataset of CWRU fault bearing dataset. So in that I am going to check the null values contained in our dataset. There is no null values in our dataset. So after that I have to display about the dataset. In description I have to check the count value, mean value, standard value, minimum to maximum value for every columns contains in our dataset. So after that I have to check the missing values. In there is no missing values in our dataset. So after that again I am going to check the preprocessed data description. So in that I have to check the count value, mean value, standard value, minimum to maximum value for preprocessed data. After that I am going to select the independent variable and dependent variable. After selecting the independent and dependent variable, I am going to split the dataset into training dataset and testing dataset. In that I am using classification. I am using two different types of deep learning algorithm like long short-term memory neural network and graded recurrent unit neural network algorithm. In our first algorithm is long short-term memory neural network algorithm. In the existing system they have used ensemble of convolutional long short-term memory neural network, but we are using long short-term memory neural network, and the long short-term memory neural network algorithm will achieve the accuracy result is 89%. So these are the performance graph of long short-term memory neural network algorithm based on accuracy loss and validation accuracy and validation loss. So after that we are checking the classification report of long short-term memory neural network for every fault type like precision, recall, and FN score for every fault type. So precision means number of correct prediction and recall means number of correct instance of prediction, and FN score means to measure the test accuracy. The overall average of the FN score is our accuracy result. So after that I am checking the confusion matrix. Confusion matrix which is used to explain the number of correct prediction and misclassification of long short-term memory neural network algorithm. So the index of a result is correct prediction, the others are misclassified results. So our second algorithm is gated recurrent unit neural network algorithm. In that algorithm which is used to achieve the accuracy result is 93%. In that we are using the same epoch for the LSTM algorithm and graded gated recurrent unit algorithm, but the GRU algorithm will achieve the more accuracy. So, and this is the learning plots of our GRU algorithm. So, this is the confusion matrix classification report of our gated recurrent unit neural network algorithm. So, this is the confusion matrix for GRU algorithm. So, these are all the variable results which are used in our program.